Okay, seniors, today we're going to be working on a continuation of working with real-life graphs. So let's go ahead and jump in. On our notes page, go ahead and write our title for today, which is Real-World Graphs. So basically what you want to do when I'm looking at graphs is, remember, graphs are used to show real-world context. Look for points in the graph where the slope changes. That will tell you that something in real life is happening as well, which is kind of what I just wrote there. Remember, if something happens where the slope changes, that means there's something changing within the problem as well. So let's go ahead and do an example. Okay, so this graph is essentially representing Marie's trip to work. Our y-axis is showing distance from home as compared to time. So this graph is showing how long it takes her to get from home as compared how long it takes her to get from home as compared to how far away she is from work. All right, so it says Marie left her briefcase at home and had to return to get it. Which point represents where she turned around and went back to get it? All right, so let's look at our graph. It looks like for 5 minutes, she's traveling 5 milliliters. At that point, it looks like for the next 5 minutes, she goes, her slope decreases, which means that at point B is the point where she stopped and turned around to get her bag. And I know that because as my slope increases, at this point here at B, it sharply decreases, which means that Marie realized that she did not have her briefcase and turned around and went home to get it, which brings her distance back to 0, which is her home. All right, it also says Marie also had to wait at the railroad tracks for a train to pass. Between what 2 points was she waiting? How long did she have to wait? So what I'm looking for is, if it says that she was waiting, that means that her slope is not going to be increasing or decreasing. It's going to be constant, which means it's not going to be changing at all. So I need to look for the 2 points where the slope is completely constant, which is between D and E. Now, our last question. How long did she have to wait? Well, let's look at our time. Our time is in minutes, and she's waiting at minute 25 until minute 30, which means 30 minus 25 is going to leave me with 5. So according to our graph, she was waiting for 5 minutes. All right, guys, make sure you have this graph roughly sketched on your notes page. We're going to be coming around to check. Let's do another example. All right, guys, let's look at this one. The graph represents Elizabeth's trip to school. How many times did she increase her speed, and did she ever stop? So again, this graph is showing us distance from home as compared with time. So the first question, how many times did she increase her speed? What I'm looking for are the times where the slope changes. So it starts out at point A at a constant rate, and then her slope remains constant at point B and sharply increases at point C, remains constant, and increases again. So she increases her speed twice. And make sure you have that written down in a complete sentence on your notes page. Now, did she ever stop? Did she ever stop? I'm looking for points on the graph where she isn't moving, but time is still going. So I'm looking for a spot on the graph where our slope is constant, meaning it's the same throughout. So if I look at my graph at points B and D, the slope isn't increasing or decreasing, it's just remaining constant, but time is still moving. So she stopped twice, which makes sense, because when you're on your way to school, you might stop twice to catch your breath or something, and then increase your speed to make sure you get there on time. When you're looking at these graphs, instead of just looking at them as lines and numbers, you really need to be thinking about what's going on within the problem. So I think the best way is just to move into some guided and independent practice. So let's go ahead and get started with that. Thanks, guys.